Awesome. Hello, I'm Jonathan Rickard. I'm an engineer on the Validated Patterns team. In this week's episode of the OpenShift Commons Special Interest Group for Validated Patterns, I'm going to talk about the imperative framework. Let me go ahead and share my screen so that way I don't get too far ahead.
You've gone through this before, at least Marty has on previous episodes. We've at least at a high level talked that we have a difference, correct?
I don't know about the imperative framework, but I know that we've talked about like different aspects of the framework, in general. Maybe, but maybe he has. I don't know. I don't remember, to be honest. So some of the things that I'm going to talk about are, I'm just going to do a recap on what is GitOps and what are validated patterns, and then go into the imperative framework that we have. And mainly it's just for if you're not familiar with GitOps, just it's a quick like high level, like this is what it is, the principles, the rules, that type of thing. And then for validated patterns, just again another recap of what they are, and how we're using the different, or how we're abiding by the rules of the GitOps foundation, as well as like making these changes in the framework to accommodate things that don't necessarily fit in a declarative way. So what is GitOps? According to Weaveworks, GitOps is a modern way to manage the cloud-native systems that are powered by Kubernetes. And it leverages the policy as code approach to define and manage every layer of the modern application stack. But really what all this means is that Git is a single source of truth. Everything is treated as code, and all operations are through a Git workflow. A majority of us, probably since the dawn of time in our technology careers, have been using some sort of GitOps approach, right? We either use like SVN or GitLab or GitHub or Bitbucket or whatever, and something like a Jenkins or GitLab CI or something like that to deploy it. So I think for a long time we've all been using it, but now we have boundaries around it, right? We have some rules that apply to it. And the other thing about this is that, like, especially in our team, we don't think that GitOps is just for cloud native environments. We think it's for everything. If you've been doing it for a long time, then anytime that you've done an infrastructure as code deployment, you've had your code out in Git, you've had your tool deploy it, everything's managed as code, everything is managed through a Git workflow. So I think that having the rules and stuff like that is nice, but I think when you say it's for cloud native systems only, it limits the capability. And so our team has proven that, like, we have cloud native deployments, but we also have virtual machine deployments, right? So like more standard deployments. The principles of GitOps are that it should be declarative, and that's everything that we need in our cluster needs to be described. So we want, like, hey, I want this thing on the cluster, and we let the Kubernetes controller, or we let the GitOps controller apply it. Versions and immutability, we get that through Git being the single source of truth. We have version control and historical context that provide the insights and into the changes that have affected the clusters. And then pulled automatically is we let the GitOps controller pull the state automatically. So there's a controller, it's Argo CD. It says, hey, what's out in Git and what's on my cluster, and then it makes it the same. And then it when it notices a difference, it pulls the difference. And then continuously reconciled, and that's Argo CD again, going out and pulling the cluster for what its current state, and pulling Git for like any changes that it might have. All right, so what are validated patterns? Validated patterns are repositories that show customers a use case in the form of Kubernetes Helm charts that describe an edge computing and hybrid cloud stack fully declaratively and comprehensively. But really, it's the evolution of a reference architecture. So if you've ever seen a reference architecture, it's a point-in-time snapshot of a configuration. Sometimes you have a great crew and they update that reference architecture and they keep it going as the system evolves. But a lot of times they go by the wayside. I'd say more often than not, you'll see a reference architecture that's outdated almost a month later after it's been published. With the validated patterns, we use CI to keep these living, right? So these are actually living, breathing demos and configurations. And so we test the latest versions of OpenShift. We test certain versions of OpenShift with new operators. And we also test new operators as they're coming out to make sure that we're identifying bugs that don't necessarily get seen in normal CI testing during the normal engineering process, because when I'm, as an engineer, developing something, I typically don't pay attention to the integrations that I have, right? So that I'm usually focused on my little bowl, and I don't really worry about the big picture. Where our team, we worry about the big picture. We worry about those integrations between operators, and we want to make sure that it all works. So part of this too is we use the GitOps model for to deliver the use case as code. As a POC, we're modifying it to fit a particular need that you can evolve into a real deployment, right? So instead of it being like, oh man, I bet we could do that, it's the art of reality versus the art of possible. And then they're highly reproducible. So you can take this code, it's all open source. You can download it, deploy it against a cluster just like we do, and you've run this fully integrated pattern demo in your environment. And we're open for collaboration. So anyone that can suggest, or anyone can suggest improvements through PRs and stuff like that, we read them, we approve them. Sometimes they're slow, but we do eventually get to them. And then they can be modified for customer needs, right? So maybe you don't need ODF, right? Maybe you have a different storage platform. You can basically pop it in. It's a little work, but you can take the ODF component out and add your storage component in. And then they're all tested, right? So once a validated pattern has been validated, it's part of our Red Hat CI and continues to be tested across product versions while the pattern remains active. So again, constantly testing OpenShift versions against new operator versions, against old OpenShift and new operator versions. So just we got this weird balance of things that kind of go into place to make sure that we're testing everything. So what value do validated patterns provide? From the customer perspective, they get you going faster, right? They reduce risk and time to value because you know that you've got this thing that you can just take and lift and shift into your environment, or just like multi-cloud GitOps, right? You can clone it and run it, and then you've got it. From a sales perspective, you don't spend a lot of time architecting. You have a tested use case that's good for base deployment, and then services can come in and make it bespoke to the customer. For partners, you have this defined architecture that you can build your solution on top of. And all the value to accelerate your sales and deployments, and then you can promote your product. So a good example is HashiCorp. Another one would be like Intel, that we've worked very closely with over the last, I don't know, what do you think, Anthony, 2 years, something like that. And then from GSIs and consulting services, you have predefined architectures that are ready to deploy. So there's a lot of out-of-the-box value that you get that you might not necessarily see when you're looking at it from the surface. And each of our patterns has these core technologies, right? So OpenShift GitOps, ACM is an optional component, but it is a component that we add in. So if you're doing multi-cluster management, that's our tool for multi-cluster management. Obviously, OpenShift and Kubernetes, all of our applications are deployed through Helm or customized, but you'll also see that we can do some of this through Ansible as well. All right, so let's talk about the imperative framework. So if you don't know me, I love Sam Jackson. Like, Sam Jackson is probably one of my favorite actors. And this GIF here, I actually send to everybody. And the reason why I think I chose this one is because, like, if you talk to like some of the really hardcore GitOps people, right? Like when you start talking about implementing Ansible, it kind of goes against the grain a little bit on GitOps principles, right? Because now you can actually start manipulating the configuration outside of the cluster. So you'll see, we're not doing that. We're trying to do better. So the imperative framework in our validated patterns framework is really, it's a framework within a framework. So using the GitOps principles, everything should be declared, everything should be as code, that type of stuff. So what we've done is we've said, okay, let's create a job or a cron job that runs a playbook that we still have all the configuration out in Git. We're still using Kubernetes and the controller to reconcile both of the changes, or both sides. But we also get a chance now where we can run some of these things that like aren't easily configurable in a declarative way. So a good example is like if you're deploying OpenShift Data Foundation on an existing cluster, you have to label those nodes if you're trying to do it, manually or through YAML. And so that's an imperative action that you'd have to take. If you're configuring certain operators, right, there's certain API calls that you have to make that you would normally do through a CLI. And so what we're trying to do here is we're trying to move those jobs or those tasks into a playbook. Now, the idea here is that each of these playbooks has to be idempotent. So idempotent means that I can run it over and over and over again, and the result will be the same. So if nothing changes, then nothing changes. It just runs and it's consistent. Oh, and one last thing is every pattern that we have, this is declared. So like this is in the Git root of every pattern. So you have a values hub, and then you have this imperative section. And so under the imperative section, you have your jobs. The cron runs every 10 minutes. You can change the timeout on the cron, or you can change the schedule for the cron, and you can change the timeout for the jobs. You can change the path to the playbooks, and that's part of our demo that we'll do. We're just gonna do like a really super simple demo. But yeah, each job is basically deployed as an init container, and we'll see how all those work out. This is just a snippet from the cluster group chart for the imperative action. So we're using a Kubernetes native object with cron, and then excuse me, this is taking the name of our job that we had in our values file. Everything's going in the imperative namespace. We have our schedule, and I'll show you how we can override that. But then, oops, got a little clicky there with my mouse. Each job name that we have, it's creating a job template, and then that's going to spin up the pod. And of course, if you have a pod, it can have one or more containers. So from a repository perspective, you can see that this is still in the root of the GitHub repository. It's under common, cluster group, and then templates and imperative, and that's where all the charts live. We've set up the RBAC so that way this job can go out and it can do the things that it needs to do. If you're trying to do something like super crazy, like maybe you're trying to create, I don't know, something silly that's new, you might have to create a new RBAC with it. But by and large, we've given it the permissions that it needs to be able to run the tasks that we needed to run without compromising anything else. So if we go and we look at my cluster here, you can see that I don't have anything except for OpenShift GitOps deployed. So all I've done is run the make install from our pattern. And Anthony, can you see this okay, or do I need to blow it up any?
I can see it just fine. I wasn't sure. Ram had his hand up for a second if he had a question.
Yeah, I just had a general question on the validated patterns. Like, who decides what pattern should be created? Like, do we let external contributors and even like I'm Red Hat, so like other teams in Red Hat, like can we contribute? I know it's probably not the focus of this talk, but that's why I just kind of maybe.
Oh, good question. No, good question. And the answer is really like anybody can create it, right? And we're not the keepers of the validated patterns, right? So we have our core patterns that we deploy. Now, whether or not that pattern makes it to like our CI, right? That would be like a process between you and us, or that team and us, right? Where we say, okay, is this something that we already have? Is this something that we see, collectively as providing value back to a sales team or the customer? But that doesn't mean that like we couldn't put it in Sandbox or something like that where it's still available from our platform, but wouldn't make it into testing, right? So say you have like multi-cloud GitOps with like I don't know, something super unique that's niche to you, and that maybe nobody's using it. Like we can have the repo out there and we can make it available and communicate it, but maybe not put it through like a testing process or something like that. You know what I mean?
Yeah, that makes sense. Like, do you have to separate out like what we like support and validate versus community contribution should be like a collective thing, right? So
yeah. And something else that we do a lot too is like we do a lot of communication through our doc site. So, say you had this thing out there and it was, that niche thing, right? We could add a docs tab, make it available through our documentation, and then that way people can kind of see like, oh, they can search by product, they can search by whatever thing. And then they're like, oh, hey, here's this one, obscure thing that's out there that, that we have. It just wouldn't be in our testing. So that way we're not wasting resources to test something that wouldn't really be used.
Yeah, I might reach out to you guys offline because I'm part of Industrial Edge. I have some ideas.
Yes, please do, because we have Industrial Edge, and like, yeah, I can't remember the guy's name that we're working with, but
Josh Swanson.
No, do you remember Anthony? I don't remember the dude's name.
Max something.
Max.
No, not
Josh Swanson is working on the Industrial Edge side for APAC, but this is the one thing that Johnny didn't mention. We will take things from anywhere, but our team in general, I mean, Johnny excluded because he was a consultant, so he knows everything, but we're not SMEs for most industries. So having folks that have worked in the manufacturing process or the oil and gas or healthcare gives color to the type of example that you want to showcase, the different use cases, and allows you to be a little bit more nuanced than, okay, this is something that does something and we really don't feel that it's adding value. It's just an example of something. So if you have, if your focus is on industrial and you can help us round out the use cases, we will take contributions from everywhere. So we'd love to work with you.
Okay.
Yeah,
cool.
100%.
So apologize, I didn't mean to dive with the focus of the talk. But...
No, dude, that's what this talk is. Yeah, so don't even, yeah, not at all. That's awesome.
All right, cool.
All right, awesome. So yeah, and Anthony, thank you for that. Because I just get going and I forget all the details. So cool. So like I said, in every repo that we have the imperative framework kind of built in, right? So if we take a look, I'm just in multi-cloud GitOps. So if I do a git remote, I'd forked it down to my organization and there's nothing here. So I'm just going to create a new branch. 3,000. All right. And so all of the imperative stuff takes place in the imperative in the imperative namespace. And okay. So we have no jobs. So if we get OC get cron jobs. Oh, helps if you. All right, awesome. So now, if I take a look in my cluster here, bam, bam. I actually need to run make install one more time. I'm silly. So what the make install is doing is it's just going out, it's making sure that we have the OpenShift GitOps operator installed. It's also installing ACM, so it's taking care of all of our cluster group application. We're deploying HashiCorp Vault along with external secrets operator, along with the imperative framework. So pretty soon we'll start seeing some of these resources getting deployed, and then we'll take a look through the repository for for like the imperative actions. I should have tmuxed it so I could switch between. But if we go back, we can start seeing that like now we're deploying the validated patterns operator. We're deploying, it'll update OpenShift GitOps here. We'll see ACM get installed. I'll give it a minute and then we'll see like the hub Argo CD. So our cluster groups are based off of a label. And in this case, the label is hub. And so what's happening is anything that has been defined in the values hub file in this directory gets applied to that cluster group name. And so pretty soon, I should have done this before I started talking, so that way we're not sitting there waiting for this thing to do its deal, but I didn't. So, but we can take a look in the namespace. So if we go and we look at imperative, and then we can look at jobs, and we can see that now we have this unseal vault cron job, and this job runs every 5 minutes. And all it's doing is it's literally going out and it's making sure that the vault that we have, so our HashiCorp vault, is unsealed and that's open, so that way we can deploy secrets to it and we can get secrets from it. And I don't know why this takes so long, but it is very slow. So on top of this, what we'll start seeing is the imperative action happens every 10 minutes. So it's another cron job that's going to get created. We're gonna just take like the existing hello world and we're gonna update it and we're gonna move it. And then we're gonna just add another item inside of our repo, so that way we can kind of see like, oh, if I wanted to add a playbook to do something, just kind of walking through it and getting it done. Try again.
One of the best things is not preparing and seeing how things work, and everyone gets to learn as far as how this is deployed in the real world, and sometimes what happens and how you correct it. So
yeah,
kudos. I know this was your plan, so well done.
Yeah, I actually went off script here a little bit and got myself out of sequence. So yes, that's why I had notes, but then I covered it up with my phone and I was looking for it over here. And I'm like, oh man, I messed up. So inside of Argo, we can see like all the different applications that are getting deployed. And again, ACM is there. If you didn't want ACM, it's as simple as removing it from a configuration file and saying, hey, I don't want the ACM resource to get deployed. This hello world and config demo, these are both sample applications that we create. So this hello world is literally just a Kubernetes app that deploys. When you go to it, just says hello world from like a domain. And then config demo is an integration between HashiCorp Vault, external secrets operator, and then Kubernetes. And going external secrets is if you've never heard of it, it's a bridge between secrets and your vault, like your secret provider. So you have Kubernetes, and ESO will translate a secret from the vault and apply it as a Kubernetes secret inside your cluster and make it available to your application. So it's an awesome project. You can template it out, so it's pretty powerful. And as you can see, like the controller here, Argo CD is going out and it's applying the state, that desired state that we were talking about, to the cluster.
Hey, Jonathan, can you talk a little bit about how ACM is used in the imperative framework?
Yeah, so inside the imperative framework, it's not used that much, right? It's more we use ACM for multi-cluster management. When you start talking about deploying imperative jobs on the on your other cluster, you would just apply it to your cluster group resource, right? So your values dash whatever cluster group.
Okay.
And because what's going to happen is the imperative job, what it'll do is it does a clone of the repo, and then it pulls all the repo stuff down, and then it applies the playbooks from within that repo. So as long as your path in your Git repo is available, when the imperative job applies it, it runs it just like everything else.
So it's really, just to summarize it, so to deploy the jobs to clusters that, like other clusters, that's why we're using the ACM. Basically the deployment. Okay.
Yeah, ACM is like when we have multi-clusters and one or basically two or more clusters, right? That's when we're going to use ACM. Obviously, if we're not, if it's a single cluster deployment, then we're not going to do anything with it. But
okay.
And once we get through this run here, I'll show you like what it would look like. And awesome, right on time. So this values hub is our default, right? So like we basically say our cluster here is hub, our main cluster group is hub, and then any additional cluster group, right? We would apply like a values dash group one, or you could call it development or staging or QE or whatever you want to call it, right? And inside of that, that's where you would define your imperative things, right? So you would say, hey, look, inside of this cluster group, I have these jobs. The name would be like hello cluster group 2 or 3 or 4 or whatever, the path to the playbooks that you want to deploy. And then when you import the cluster into ACM, you apply the cluster group label and then this stuff would get applied to it the same way that we're applying it to our hub cluster. Without trying to overload the term hub, it's all the cluster group label. So if we do an OC get jobs minus n imperative, we can see that our initial imperative cron job is there, right? So if we do an OC logs, going to kick out, and we can see that, oh, spelled wrong. Oh.
So these are probably some of the things that, like, let's say a developer that wants to leverage the imperative framework, like what would they care about? Like, what would they need to know, right? Like, what are the things that you probably like, if you could like kind of separate out, like, you know, what, like the platform things that probably like somebody who wants to leverage this won't care much about, versus, like, I was trying to kind of understand that little bit. I don't know if you can like kind of talk through like what like someone who wants to leverage this would have to know, or like that experience or that journey for that developer versus the platform. Like, that would be great.
Yeah, I think from a developer perspective, it comes down to you'd have to know Ansible, right? How do I deploy this application in an idempotent way, right? That's repeatable, so that way you're not deploying something that's going to break the second time you run it, right? And we had one guy, or one team rather, that deployed a pattern, and they were using Ansible to configure Keycloak. And so like what they did is they deployed everything through the framework, and then it was just easier for them to configure the Keycloak, you know, organizations and users and stuff like that through Ansible. And so that's what they used Ansible for, or that's what they used the imperative framework for. So from a platform perspective, you would just need to know where to declare it at and how to define it. And then from a developer perspective, right, you just need to know how to deploy it through Ansible. And obviously I'm speaking at 1,000-foot level, right? So if there were some like really intricate things that you're trying to do, then it would just being aware of how to make those things interact with each other, right? So if maybe you're going out and you're deploying something, you need to wait, and then you go and grab something from the newest thing that you deployed, and then you're going to apply it to a new thing. Like, you just need to know how all that logic works, and then understand how do I make it flow, so that way it's idempotent. And I can't say anything, so if you're raising your hand, just go.
Sorry, it's just me. The only thing I want to add in this is that when you understand the reason you're doing it for developers is so that you can abstract all the complexity.
Yeah.
What we're building here are use cases. So certain things have to happen in order. Johnny mentioned before labeling disks. You could go through and create routers. You can create DNS entries. You can do all kinds of things that you need to run the commands rather than just letting Git decide how it's going to satisfy that request. So when we put these all together, it is the full use case that you can make it easy for the developer to say, hey, I don't really need to understand how this whole pipeline works for DevSecOps, or creating something with AI/ML that you're going to bring in a bunch of individual files to be processed through a ML model. You just go and set up this inside a pattern, and now all we are is a deployment mechanism.
Yeah.
And the imperative part is just what do you need to run commands in a specific order, and we can preempt that so that we're not letting GitOps do it all on its own, but setting things up ahead of time, deploying something, waiting for it to finish, and then continuing on. And that's the strength of what Johnny's talking about right here.
Yeah, because the alternative is creating jobs, right? You'd have an individual job inside your repo that does it's either a shell script or not, maybe even another Ansible playbook or something, right? But it would have some code of some type, and you'd have to run it as a job, and then it comes down to, like, now you're using like the controller features of like sync waves and sync hooks and stuff like that, and you're hoping that you catch it in the right flow, because if you've ever used them, they're not very consistent, right? And it's hard to balance a deployment based off of that, right? So you end up having a job that does a wait, and then a job that does the task once that wait's complete, and then a job that maybe notifies something else, right? So you end up with all these different jobs, where on the other hand, you could use something like this, where it's like, okay, let me run these tasks, let me go out and verify that the thing is there. And then you're using a tool that you still know, like Ansible, or it could even still be a shell script or whatever, but you're using the framework still in a way that you're familiar with to take care of these tasks. It can get gnarly. Like if you look at medical diagnosis from when we first started, there's jobs all over the place. I mean, like we were doing jobs for everything.
That's what I was trying to figure out between a standard like cron job in Kubernetes versus like doing it this way, right? What's really the difference?
Yeah, the difference is it's one job getting deployed, but all your code is in Ansible, and versus the alternative, which would be like one job per task, right? Going through your application to do the thing that you're either waiting, or maybe you have one job that it's just a giant script, right? And the first part is to wait for a resource to become available. And obviously you can use health checks and stuff like that, but there's sometimes where you need the operator to be completely available to come up before you start making API calls to it. And so, things like Quay, right? Where I need that registry to be completely available and configured or integrated before I can start actually making API calls to create the user, create the permissions, the organizations, all that stuff, right? So that can be a really nasty, and actually we have one, and it can be really nasty, and it can be a really nasty shell script, or you can put all that stuff in a playbook that you're familiar with, and just let the framework go out and do it, and then just keep making sure that it's good to go. Hopefully that answered your question. I know I kind of answered it at like a very high level, but it's when you get in the weeds when it starts getting a little. It's I mean, there's so much you can do.
Yeah, definitely. Like I said, I'll get hands on and probably it'll be more clear. But yeah, I get the idea. Thanks.
Yeah, awesome. And if you have any questions, please feel free to reach out. Like we will answer. We'll answer them.
Yeah, sounds good. Cheers.
Awesome. Yep. Thank you. And so inside each job, we have these init containers, right? So this fetch CA, we just implemented a internal Git. So if you don't, maybe you're a customer that doesn't have a Git service, and so what this does is it goes out and it grabs the CA from that Git instance, and then it adds it into your CA for the cluster, so that way all the tools can use it. This git init is the first step that runs, and it basically just clones the repo down and makes the playbooks available so that you can run it. And then this is that hello world that was part of the initial everyday deployment. So now what we're going to do is we're just going to copy this hello world from common and put it in the path, and then make it available, so that way we have a second job, so you can kind of see how we use the framework. So I'm just going to do a copy -r on common Ansible, and typing while people are watching is not fun. All right, so we have the Hello World app in Ansible. So let's go ahead and modify this. And we're going to name the config map that gets created. We'll call it GitOps SIG demo. All right, and so now, again, I'm just going to add another list item for this playbook. Come on, fingers. All right, so I'm going to leave the hello world that we had that just gets deployed, but I'm adding an additional playbook, or an additional job, an additional imperative action called SIG demo hello world. The path is in the repo itself, right? So it's going to be in the Ansible directory under hello world, and then hello world.yaml. Now, if you had roles, you could use roles. I'm looking into Ansible pool to see if like there's some functionality there that we get that we don't necessarily get with this, but for today, like it's running a playbook as normal. All right, so I'm just gonna quit and save out of this.
If you didn't
LOL.
notice, it's Johnny's just following good hygiene and adding in comments as he commits things. Yeah.
All right. So now eventually this is going to show up under imperative jobs. Let's see here. Yes. All right, so we just made a change. We're pushing it out. We're letting the controller apply it to the cluster. And what we'll start seeing is that that SIG demo hello world job get added. So if we're doing OC jobs, it hasn't run recently. So once it runs, it'll run, but we'll see it. But we can see that the imperative action runs every 10. The unseal the vault job runs every 5. And it's just using a simplified process, right? Well, a simplified process from a developer's perspective, right? It's you take the things that you have, the things that you know, and you put it in a common place, and then you let the framework pick it up and apply it. All the hard stuff, right? It's all behind the scenes, and so I think that's a lot of the value. It can also be a little daunting sometimes if you're the person that needs to know, like, I need to peek behind the curtains and see what this thing is doing. But everything that we have is in it's in common under cluster group, so all the imperative framework is there. All of our builds for our images are in they're all in Git. The repos are all in Git. They're all open source. So we're not hiding anything. We're putting it all out there, and you know, if you have ideas or if you have contributions that you want to make, like, please feel free to make them, because we need them and we need the help. And Anthony made a good point earlier. We're not the experts in this stuff, right? So a lot of times we're going with what we know and what we found, like, through research. And there's always a perspective that we're not getting, right? When we're doing this thing, right? We're coming at it from a very specific view. And so to have perspective from the outside, like, oh, well, maybe you do this because of this and this and this, and like, oh yeah, I would have never thought of that, you know? So I mean, no idea is a dumb idea. Like, we'll take them and we'll consider them. We might not apply everything, but we will definitely consider all of them. And I'm just waiting for this cron job to run so that way I can show you that it actually works. And then we'll see, like, another config map here called SIG demo hello world, or whatever we ended up naming it. Are there any questions or anything like that while we're waiting? Comments?
The one thing we didn't really talk about here, Johnny, is the fact that imperative works just fine in collaboration with the OpenShift GitOps, and that's what you're highlighting here. But we also have an Ansible GitOps framework that's in process as well, which combines the two just as easily. Everything we're doing here is based on the Argo CD and the OpenShift GitOps, but Ansible, we have that ability to do that as well. Do imperative while GitOps.
Yeah, exactly. And it's using the what's it called, Anthony? The AAP, Ansible Application Platform, right? Ansible Automation Platform, AAP. And yeah, so it's using that along with Argo to make some of these it's using that as part of the GitOps framework. And so yeah, it's a pretty cool thing. Marty put that together, and it's pretty awesome. So
the comment with EDA question mark enterprise
yes,
automation.
no, event driven.
Event driven.
Yeah.
Oh, not. I don't know if there's event-driven Ansible yet. It's basically AAP, and GitOps, right? And it's just going out like it's configuring virtual machines. So the idea is, you have maybe you just deployed 100 VMs, and in the demo, it's you're deploying 2 VMs. You're applying a kiosk application to it, and what's going on is like GitOps is deploying the VMs. It's waiting for the VMs to come up, and then it's using Ansible to apply the application. I think is what it is, or maybe it's Ansible creating the machine set. It's been a while since I looked at it, but it's not event driven, but it's definitely like it's all the things are there for it. It's just it would be some light testing and having a good demo for it.
Yeah, we use EDA to actually build device edge images. That's why I was asking.
Okay.
If the Ansible GitOps thing is using EDA.
I don't believe it is to start with, but we just created it about 9 months ago, and Marty Jackson is the one that worked on that with several folks inside Red Hat.
Yeah.
And they built it out so that it deploys AAP and satellite, kind of greenfield for a RHEL opportunity to just lay down some foundational infrastructure. But we are looking to extend it for other use cases and have other examples that use it. Over the past couple of years, when we built out the Validated Patterns initiative, we focused on OpenShift just because we had more examples, more demos, more use cases based on the OpenShift containers. Whereas we're seeing those additional needs outside of OpenShift to get started, and then maybe connecting to have both working at the same time. But if you have ideas with the event-driven Ansible, if there's some other ways we want to enhance things, as Johnny said, this is all open, so we're very interested in extending it. With
like we have, like as I was saying earlier, like for building like device edge images, like a GitOps way, like we're using like Ansible EDA. Okay, so the blueprints, like, and the image builder stuff, right? Like the blueprints sit in a Git repository, and then you go make changes to it. The EDA webhook picks it up, and then it triggers a job, in the controller. So we're already using that. That's why I was kind of wondering, like the Ansible GitOps pattern, you guys using EDA. So,
that's awesome.
If you have an example or some thoughts, we'd love to incorporate what you've already done.
Okay.
Yeah, and one thing to add to, right? Like we don't want the glory. Like we don't want the fame. We don't want the recognition. Like this is your baby, right? So like it would be one of those things where if you came to us and you're like, hey, we've got this thing. If you're worried about like, now I'm not saying that you are. I'm just generally speaking here, but like, we don't care, right? It's your thing. We don't want any of the notoriety for it. Like it's your project. We want you to maintain it. We don't want to be the experts on it. We just want to make sure that it's available in this way so that people can reuse it. So we're more of a broadcaster of your work, right? Like we just want to make sure that your work is recognized and it's used, and that from a Red Hat perspective, right, that we're not wasting resources with 10 groups doing the same thing over and over and over again in different ways. Like let's just figure this stuff out. That EDA thing, I'm telling you right now, sounds amazing. I'm super excited about like just talking to you about it because that's from a nerd perspective, it sounds awesome.
Yeah, it's cool. But the interesting thing is the OT folks, it's too much, right? The GitOps and like a lot of new technologies pushing their way. So but like from an IT perspective, it's fine, but like I find that OT folks are like, I don't even know what you're talking about.
What is happening right now? All right, well, this is going to take forever just to show you that there's a new config map that gets made. But yeah, so after the cron updates, it's just going to run through. It's going to run the init job again. It's going to apply the playbook from the directory, and then we'll have another config map that says SIG demo hello world. So Anthony, I don't know if we want to kill it or if we want to wait for this thing to complete because it might be a couple more minutes.
A couple more is fine as long as we have time. I mean, we got 10 minutes before the top of the hour. I know most of us probably have other calls that we have to get to.
Oh yeah, so here we go. We can see it starting to kick off. I'm sorry, I didn't mean to cut you off.
You're jumping the gun. It's okay. You're excited. I appreciate it. It's awesome.
Yep. I'm a nerd. I can't help it. So if we do an OC logs here, you should see. Oh, this is unstill playbook. Okay, wait. Let's calm down, Johnny. Gotta wait. I got excited, Anthony. It was too soon.
It's all good. Any other questions you guys have while we're waiting? Because I know that it shouldn't be too long, but
all of these are running on the local cluster, right, where the hub is installed. But it could potentially run on other clusters, as you were talking about, right, with ACM before.
Yeah.
Okay.
Yeah, and normally what we would do, so like this values group 1 here, this would be like your values dash, like say maybe you had development or staging as a secondary cluster, right?
Mm-hmm.
It would be a label that you wanted to give it just for you to identify it, and then when you import that cluster into ACM, you would define your imperative section just like you did on this on this cluster here, right? So you'd say, hey, my playbooks are here. I want them to run at this timeout, whatever. Here's the image that I want to use if you wanted to override the image. And yeah, then what it would do is it would apply those jobs on that remote cluster.
Mm-hmm. To me, it sounds like it's kind of bringing some of the, like, how in Ansible automation platform, like you can schedule, like define a job templates and have it scheduled to run, and it can run on an inventory, like a set of hosts that are defined in the inventory file. Like it sounds like similar thing, but bringing into that kind of the Kubernetes world, like a declarative way of saying, hey, here's my things and I want you to run, and here's all the target clusters I want you to go run this. So basically gives you a framework to do that kind of in a Kubernetes native way. Seems like, is that like a correct understanding?
Yeah, and the idea is, like, when we first started talking about doing this, like I don't want to call it pushback, but we definitely got some raised eyebrows about implementing Ansible with GitOps. And so this was kind of like working within the rules, so we have those four whatever they are, the elements of GitOps, like trying to work within those rules as far as like not letting Ansible get like super configured, like getting out and going out and just doing a bunch of crazy stuff. So it's very like, all right, let's configure everything as code. Let's let GitOps control it, and GitOps can apply it and make sure that there's no diff, and then just working within the rules of the GitOps principles. And then once we did that, I think that there was a lot less hesitation about it. And yeah, you're exactly right. We want to be able to declare it, let the controller go and reconcile it, and then call it a day, right? And not have to deal with it too much. Where on the Ansible side, I think we use Ansible a lot more for what Ansible was intended for. You know what I mean? Especially with AAP and stuff like that. Like that's a tool that's meant to apply playbooks and roles. So it's meant to apply Ansible code to target hosts. And yeah, that's on the Ansible GitOps side. That's exactly what that's doing. It's very, very focused on using Ansible for that target versus like OpenShift.
Mm-hmm.
The other thing to keep in mind is we spent a ton of time talking and debating over push versus pull, especially on the edge. So do you want the edge node to pull, come back and grab something from a central site, or do you want to be on the central site and push it down to the edge? This is one of the ways that we talked about having it be more of a pull model from the edge, so that you don't have those timeouts or having things working where you don't have downtime right now, but it's going to push out a change and it's going to update it anyway. So
yeah. I definitely I'm gonna reach out because I have a customer that's like looking to do this pull model, because we can talk more offline, but I might reach out to you because I'm curious now if this could be a fit to what they're, some of the use cases that I'm seeing there. So definitely reach out to you offline.
Yeah, definitely. Please do. And let us know.
I sent you a Slack, so you should
Yeah.
you should have a connection there. But we're open. I mean, if you look at what's in the library right now, just in the first quarter, we had 7 new patterns developed by Intel, as Johnny had mentioned. So we're open to, even external to Red Hat, people reaching out and engaging and saying, these are things we're seeing. Can you help us with the framework? And how do we start using things? Because it just gets, it makes everyone's demos better if you know that they can be tested over time. And it's not just a one-time thing. And that's what we're trying to do. We're trying to sit in the middle and help everybody, as Johnny said.
Yeah.
Cool.
So just real quick, so we can close this out. So inside the job here, you can see that we have the SIG demo init container. And then if you look at the logs for that container, we can see that the playbook ran. And then if we look, we have our config map for SIG demo. It helps when you click on the thing. I'm using a different web SSH, so it wasn't copying it when I was clicking on it. So I actually had to go in. That's why I kept looking at the wrong one. Anyways, I'm done. But yeah, it all worked. All using the imperative framework. It was just putting playbooks in place. So no code changes really, just kind of like making like small little name changes, right? Which is something that we would do. And then letting the framework kind of take it over. Now, something that it's, as we're talking about this, right? Like the one thing I think that, or the one point that I really want to make is that like this isn't the answer for everything, right? If you can make it declarative and keep it in YAML and keep it in, a Kubernetes native way, 100%, that's the way that we want to do it. This is really to implement those things that are very difficult and time consuming and things that like, I have to go out and make a change. I have to do this, right? It's not something that is it's not like a manifest that I can apply. It's something that I have to go and maybe I have to go and hit like an API to get a token back or get some value back and then use that for something else. It's really what that's for. And it's to help simplify that process. So we don't want this to be I'm going to create a job and let the job do everything, or I'm going to create a playbook and let the playbook do everything. We want it to be like a tool that's in your tool belt that you need for a specific thing. You don't use a drill to take the batteries out of a remote. You use a little screwdriver. So just keep that in mind. But yeah, hopefully this was informative. Hopefully I didn't go too deep and put you to sleep. And yeah, that's it.
Any final questions, you guys? Stunned silence. I agree. They're probably just muted and clapping. I would be them too. Unfortunately,
Yeah,
muted.
No, thanks for doing this, by the way. Great job. Appreciate it.
Thank you.
Yes, awesome presentation. Awesome.
Thank you. And shameless plug, if you have time tomorrow on the Asking OpenShift Admin live stream, we have IBM coming on to talk about HyperShift and I'm sorry, I'm a bad product guy. Hosted control planes and ODF and add-ons in the cluster and stuff like that. So that should be a pretty interesting topic. So check it out.
From a cross-product or cross-initiative perspective, there's all sorts of additional areas that you can find education. Ask an OpenShift admin, GitOps Guide to the Galaxy are ones that Johnny is part of because, like I said, he's an expert in a lot of different things. Beyond that is also the Red Hat user groups, which are held locally, or our Summit Connects, which are also held locally in several cities. So if you're interested in any of those, feel free to reach out. I had mentioned Slack Basic earlier, and for the OpenShift Commons, if you're trying to get in touch with this team or anyone else, there is an OpenShift Commons Slack that you can join from outside of Red Hat or from anywhere and just work with some of the experts that we have on these sessions and ask questions after the fact. So you don't have to, this can be recorded. You can listen to it and still engage in the conversation. But with that, we can close it out for today. I'll stop the recording here, and thanks everyone for joining and for listening after the fact.
Yeah, and thanks for the questions and the conversation. Really appreciate it.
Have a good one. Cheers.
Yeah, see ya.